Hello everyone, I'm João from That's Brilliant. In this video, we're going to solve two exercises about electric charges. So we have some videos in That's Brilliant talking about the introduction to electricity, talking about what makes an object electrically charged. I'm going to put the links of those videos in the description below. So I'm going to solve two simple problems involving two simple problems about electric charges. So, imagine you have a number of electrons equal to x. You have x electrons. X is the number of electrons. And you have, and remember, it's all electrons. Don't have protons in this case. It's a lot of electrons together. And the total amount of charge you have there is equal to, the charge is equal to negative 8 times 10 to the power of negative 15. And what do you want here? You want to know what's the value of x. So the question in other way of saying is, you have this charge. How many electrons you need to have this charge? So remember, it's all electrons, no protons in this exercise. You want to know how many electrons you have to put together to have this amount of charge. And as you can see, it's a negative charge, obviously, because the charge of electrons is negative and you won't have electrons. You won't have electrons here. So, let's remember the equation we saw in the video about what makes an object electrically charged. So, and I want to talk a little bit about this equation, because I want to explain something maybe I didn't talk about in that video. So, you have this equation. The charge of an object is equal to number of protons minus number of electrons times E. And E is a fundamental charge, the charge of one proton. And remember, E is equal to 1.6 times 10 to the negative 19 coulomb. So, why do you have number of protons minus number of electrons? I want to explain this. And basically, we saw that the charge is always going to be an integer multiple of E, because you can have half a proton and then half E. No, you have an integer number of protons and an integer number of electrons. So the total amount of charge is always going to be an integer. You have always an integer of protons and an integer of electrons. So Q is always going to be a multiple of E. For example, if you have one proton and two electrons, the total amount of charge is the charge of one electron, because one electron neutralizes one proton, and what is there left is one electron. So the question is, here we can understand it's going to be an integer multiple of E. Q is going to be an integer multiple of E. But why is it number of protons less minus number of electrons? Why it isn't number of electrons minus number of protons? Because, and the answer is, because if you put this way, imagine if you have more protons than electrons. For example, imagine you have 5 here and 2 here. You have more protons than electrons. So this operation here, the number of protons minus the number of electrons, is going to be 3. It's going to be positive. And we know that we have more protons, more positive charges than electric charges, number of protons greater than the number of electrons. It's going to be a positive charge. So if you do it this way, number of protons minus number of electrons, we don't have to be concerned about the positive or the negative. The sign is going to be already in the math. Because if you put the other way, you are going to reach a number with the wrong signal, or positive, and it should be negative. So if you do this way, the positive or the negative already appears with the math. Imagine you do the positive. You have 2 protons and 5 electrons. You have more electrons than protons. So the total amount of charge should be negative. And when you do this math, it's going to be 2 minus 5, negative 3. So can alternate it here. But if you do the opposite way you are doing here, you're going to correct the signal in the end, the positive or the negative. You're going to have to think if you have more electrons and more protons, and then change the positive or the negative. If you do this way, protons minus electrons, the positive or the negative already appears with the math. So it's simple. It's more simple than doing another way. So this is what I wanted to explain briefly in this video, and let me write it again. We have the number of charge is number of protons minus number of electrons multiplied by E. So here we don't have protons, so number of protons is 0. So we have that the total amount of charge is negative number of electrons multiplied by E. So let's put the numbers here. We know that the charge of this amount of electrons is negative 8 times 10 to the power of negative 15. Number of electrons is what we want to know, and E is the fundamental charge, that is 1.6 times 10 to the power of negative 19. So we can multiply both sides by negative 1, so it's going to be positive and positive. And then you can divide both sides by all of this. So we're going to have number of electrons is 8 times 10 to the power of minus 15, over 1.6 times 10 to the power of negative 19. So, how do you do this math? Let's just talk about 8 and 1.6. Multiply here and here by 10. So 8 times 10, 18, and 1.6 times 10, 16. So 80, here is 80, 8 times 10 is 80. So 80 divided by 16 is 5. And then 10 to the power of negative 15 divided by 10 to the power of negative 19 is 10 to the 4th power. So here we have 5 with 4 zeros coulomb. This means 50,000 coulomb is the value, sorry, it isn't coulomb here. 50,000 is the number of electrons. Okay. Coulomb is the unit for charge. Here is coulomb. Here is the number of electrons. So we solved our first exercise. Now it's the last one in this video. We have something like this. The total amount of charge, and this is another thing. Okay. The total amount of charge is 6.4 times 10 to the power of negative 17 coulomb. The number of protons here, let me put NP. The number of protons is equal to 10 to the power of 20. And we want to know the number of electrons. So let's use that equation. We have the charge is number of protons minus number of electrons multiplied by E. This is the equation we deduced earlier. So the total amount of charge, and it's positive here. I forgot to mention, but it's a positive charge. The total amount of charge is positive. And by this information, we can assume that the number of protons must be greater than the number of electrons. Because if the charge is positive, we have more protons than electrons. More positive charges than negative charges. So 6.4 times 10 to the negative 17 is equal to number of protons 10 to the 20 minus number of electrons multiplied by E. E, the fundamental charge, 1.6 times 10 to the power of negative 19. So we can divide both sides by 1.6 times 10 to the power of negative 19. So we're going to have 6.4 times 10 to the power of negative 17 divided by 1.6 times 10 to the power of negative 19 is going to be equal to 10 to the power of 20 minus number of electrons. And here we have our equation with only one thing we don't know, it's the number of electrons. So let's make the math simple here. 6.4 divided by 1.6 is 4. And 10 to the power of negative 17 divided by 10 to the power of negative 19 is 10 squared. Is equal to 10 to the power of 20 divided minus number of electrons. So we can what we can do here? We can add number of electrons to both sides and then subtract of both sides of this here. So we have number of electrons is equal to 10 to the power 20 minus 4 times 10 squared. What I did here is add on both sides an e and subtract from both sides 4 times 7 squared. So what you can do here, you can, for example, put it this way. Number of electrons is 10 squared multiplied by 10 to the power of 18 minus 4. And this is the number of electrons you have. So this is it. We solved 2 exercises. Please, any questions, leave them in the comments below. Thanks very much for watching, and I see you in the next videos.